Welcome friends, in this video let's discuss about El Nino, La Nina, El Nino Southern Oscillation and geographical effects of El Nino in different parts of the world including India. Okay, so first let's look into what is an El Nino. El Nino is an abnormal weather pattern. Please remember it is an abnormal weather pattern that is caused by various factors. These factors include warming of the Pacific Ocean near equator off the coast of South America. The second factor is the normal trade winds weaken during El Nino events. So weakening of the strong trade winds during El Nino events, that is the second factor. Third is that warm water that usually found in the Western Pacific flow towards the east during El Nino events. So these three factors causes the El Nino. So this warm water which usually present in the Western Pacific Ocean displaces cold water that is normally found near the surface of Eastern Pacific, setting off atmospheric changes that affect weather pattern in many parts of the world. Okay, that is the consequences. So if you still have not understood the El Nino event, I am going to explain this with the help of a diagram in the coming slides. Please don't worry. So during the normal year, this is what happens during the normal year in the Pacific Ocean. Okay, during the normal year, strong trade winds blows from east to west. Okay, equatorial currents. Strong trade winds blows from east to west. Okay, so this trade winds carries warm surface water from eastern side of the Pacific Ocean to the western side. Okay, so this makes warm Pacific pool. Okay, pool of warm water off the coast of Australia and Asian countries. Okay, so this brings warm water towards the western part of the Pacific Ocean. That is called warm Pacific pool. So this is due to the strong trade winds which blows from east to west in the Pacific Ocean. Okay, so alternatively, the strong Peruvian current, that is Humboldt current, passes through the Peru and Chilean coastal line. So this intense Peruvian current causes upwelling of the cold water along the west coast of South America. Okay, so upwelling of water brings nutrients to the surface, which helps to harvest rich fishes in the coast of South America. Okay, so that is the normal year. Okay, normal year. So warm sea surface temperature in the Western Pacific pump. So this is the Western Pacific. Okay, this is the Western Pacific. This is the Eastern Pacific where South America is present. Here, warm sea surface temperature in the Western Pacific, because of the trade winds which carries warm water to the Western Pacific, pump heat and moisture into the atmosphere. Because the warm water, it reduces the pressure, atmospheric pressure, and which helps to build the cumulonimbus clouds. Okay, so warm weather condition helps to build the clouds, and rainfall is the resulted. Okay, so this now drier air in the atmosphere then travels before descending over the cooler eastern tropical Pacific. So this dry air travels to this direction, the eastern direction, and descend on the coast of South America, that is Eastern Pacific Ocean. So this pattern of rising air in the west and falling the east with westward moving air at the surface is referred to as Walker's circulation. Okay, Walker's circulation. So here this is the region of low pressure. This is the region of higher pressure, because here, because the warmer surface, sea surface temperature and warmer condition, rainfall occurs. Okay, so after rainfall, drier air passes through atmosphere and reaches the Eastern Pacific coast and descend here. This results in higher air pressure. Okay, that is the Walker cell, the normal years. So this diagram shows the southeast trade winds usually passes from east to west. Okay, so which is resulting in the carrying away of warm water from east towards west, causing Western Pacific pool, which results in the rainfall on the coast of Australia and Asia. Okay, so that is the issue here. So along with that, during normal years, it causes upwelling on the coast of South America. Normally, strong trade winds blow westward across the tropical Pacific region, the Pacific Ocean located between Tropic of Cancer and Tropic of Capricorn. So these winds push warm surface water towards the West Pacific where it borders Asia and Australia, as I already discussed. Okay, so this strong trade winds pushes warm surface water towards the western Pacific, that is Australia and other Asian countries. So due to the warm trade winds, sea surface normally above 0.5 meter. So normally there is a sea surface above 0.5 meter on the western Pacific Ocean. Okay, so this is 1 feet higher water here than towards the eastern Pacific Ocean. Okay, so that is the major event during normal years. So the westward movement of warm water causes cool waters to rise up towards the surface on the coast of Ecuador. So cold water descends down in the western Pacific and move towards the eastern Pacific, towards the coast of Peru and Chile. Okay, so this cold water upwells because of the Peruvian current, Humboldt current, which carries the cold water to the surface along with nutrients. So this process is known as upwelling. Upwelling elevates cold, nutrient-rich water to the euphotic zone, the upper layer of the ocean. So nutrients in the cold water includes nitrates and phosphates, which are essential for the growth of phytoplanktons, minute plant-like organisms. So these are the food for smaller fishes. Okay, zooplanktons. So zooplanktons are in turn fed by small fishes. Small fishes are the food for the largest fishes. So this helps in the proliferation of the population of fishes. So this is a location of rich fishery in South America. So in normal years, South American people harvest rich fishes on the coast of South America. Okay, so that is during normal years. Now let's look into the events during El Nino. Okay, so El Nino is the warm phase of El Nino Southern Oscillation, commonly called ENSO, and it is associated with a band of warm ocean water that develops in the central and eastern equatorial Pacific. Okay, so here the warm ocean water develops in the central and eastern central equatorial Pacific. Okay, so it was not the case during normal times, as I was discussed here. So during El Nino event, the trade winds, which was usually stronger, becomes weakened. Okay, so weak trade winds, for this, unable to push water towards the western Pacific Ocean. Okay, so because the weak trade winds, the counter current set in motion. So trade wind diminishes, leading to eastward movement of warm water along the equator. Okay, so as a result, surface water of the central and eastern Pacific Ocean becomes warmer. So with far-reaching consequences to weather pattern. Please remember, trade winds, which usually is stronger, becomes weak during El Nino, which prevents to push the surface water towards the western Pacific Ocean. So inability of the trade winds to push warm water towards the western Pacific leads to movement of water towards central and eastern Pacific Ocean. Okay, warmer water. So this results in above normal temperature in the western Pacific Ocean. Okay, so because of less warm water on the coast of Australia, that is western Pacific Ocean, temperature reduces and air pressure increases here. It is reverse of normal event. And here, because the warmer sea surface temperature, air pressure reduces and temperature increases, which results in undesirable rainfall on the coast of South America. So that is the event here. Okay, I hope this help you in understanding. So during El Nino event, trade winds weaken, as already discussing, or may even reverse, allowing the area of warmer than normal water to move into the central and eastern Pacific Ocean. Okay, so warmer water moves towards this rather than here. So these warmer than normal ocean temperature are associated with a deepening of the thermocline in the central and eastern Pacific. So a weaker upwelling of cooler ocean waters is resulted here, which usually was stronger. So sea surface temperature around northern Australia are cooler than normal here. Okay, so here it is cooler than normal, and the focus of convection migrates away from Australia towards central and eastern Pacific. So usually in Australia, because of the warmer climate, convection sets in motion, results in rainfall. But because of the cooler climate, because of El Nino events, this convection shifts eastward towards central and eastern Pacific Ocean, and this leads to rainfall here, rainfall in the central and eastern Pacific Ocean. So here this results in increased rainfall for nations such as Kiribati and Peru, but less rainfall over the Australia. So that is the reversal of sea surface temperature. So El Nino is accompanied by high air pressure in the western Pacific. Okay, here it is the higher air pressure in the western Pacific and low air pressure in the eastern Pacific, because warmer Pacific pool is reduced here because during the El Nino event. This results in a cooler climate and higher air pressure. Here it is lower air pressure and warmer climate. Okay, so that is during the El Nino event. El Nino Southern Oscillation refers to the cycle of, let's discuss about this, El Nino Southern Oscillation. So this refers to cycle of warm and cold temperatures. This is the cycle of warm and cold temperatures as measured by sea surface temperature of the tropical central and eastern Pacific Ocean. So El Nino Southern Oscillation, here it is sea surface temperature is measured on the western Pacific Ocean and central Pacific Ocean. Here the Port Darwin, we measure sea surface temperature and air pressure, that is the western Pacific, and central Pacific in Tahiti. Okay, so that is the issue here. So Tahiti and Port Darwin, we measure the pressure difference between these two places. So the cool phase of El Nino Southern Oscillation is called La Nina. Okay, La Nina. Here during La Nina, sea surface temperature in eastern Pacific is below average. So temperature is below average in eastern Pacific and air pressure high in the eastern and low in the western Pacific. Okay, air pressure is higher in the eastern and low in the western Pacific. So this results in above normal rainfall in India and Australia, La Nina. Okay, so because of the lower pressure, higher temperature in the western Pacific and higher pressure, lower temperature in western Pacific, this results in above normal temperature in Australia and India during La Nina events. That is called cooler phase of El Nino Southern Oscillation. Okay, so warmer phase is La Nina, that is reverse of El Nino. Okay, so El Nino Southern Oscillation cycles, both El Nino and La Nina cause global changes of both temperature and rainfall. Okay, so this is about the issue. So El Nino Southern Oscillation, this has already been discussed. So I repeat again, Southern Oscillation is accompanied by atmospheric component coupled with sea surface temperature. So El Nino is accompanied with high and La Nina with low air surface temperature in the tropical West Pacific. Okay, so the two period last several months each, which vary depending upon the geographical situations. So the impact of Southern Oscillation are rampant. Okay, so low Southern Oscillation index, that is the pressure difference between western and central Pacific Ocean. If there is a small pressure difference, that leads to El Nino event. This may be important from Pune's point of view. If there is small pressure difference between those two locations, that leads to El Nino event. So trade winds become weakens and it leads to deficit monsoon. Okay, so in the higher Southern Oscillation events, it leads to a higher difference between pressure from Port Darwin to Tahiti. Okay, that leads to higher pressure difference, leads to La Nina event. So this leads to strong trade winds, hence La Nina occurs. Above normal rainfall is resulted in India and Australia and other parts of the world. So that is about El Nino. I hope that helped you in understanding the event. Typically, El Nino is an anomaly that happens at regular intervals of 2 to 7 years. So and it lasts for 9 months to 2 years. Okay, the last El Nino event which occurred in India lasted for 2 years, more than 2 years. The average period of length is, however, is 5 years. So when this warming occurs for 7 to 9 months, it is classified as El Nino conditions. Okay, so when this duration is longer than 9 months, this is called El Nino episode. That is not desirable for India at least because of the drought situation which are faced in India. So effects of El Nino are felt in all parts of the world. For example, it causes flooding in certain parts, hurricanes in some parts, and drought and fires in other parts of the world. So flooding is caused in Bolivia, okay, because of warmer climate and lower air pressure. Okay, so flooding in Bolivia, Ecuador, northern Peru, okay, and also in Cuba and US Gulf states. Okay, so flooding occurs in these regions. Hurricane in Tahiti and Hawaii. Okay, Tahiti and Hawaii. Drought and forest fires are resulted in India and Australian parts. So drought and forest fires, we are facing severe drought during El Nino events. So drought and forest fires are observed in South Africa, India, okay, whole India, Sri Lanka, Philippines, Indonesia, Australia, the whole of Australia, southern Peru, even southern Peru, Bolivia, Mexico and Central America. Okay, Mexico and Central America also witnesses drought here. So these are the issues. You need not remember these numbers. Okay, so that is outdated. Only for explaining the effects I have kept this table. So La Nina, that is about El Nino. So La Nina is a reverse of El Nino. Okay, if you understand El Nino, then it is easy to understand the La Nina. So La Nina is a positive phase of El Nino Southern Oscillation, and it is associated with cooler than average sea surface temperature in central and eastern Pacific Ocean. So this is due to the cooler than average sea surface temperature in central and eastern Pacific Ocean, and along with that the trade winds are stronger than normal. Okay, so that causes heavy rainfall in the western Pacific Ocean and India and other parts of the world. So name La Nina originates from Spanish meaning the girl, and analogous to El Nino, that means boy, because El Nino events occurs off the coast of Chile and Peru during December months. So during December it is associated with Jesus Christ, so they named that as boy. Okay, so during a period of La Nina, sea surface temperature across equatorial eastern central Pacific will be lower than normal by 3 to 5 degrees Celsius. Okay, so La Nina is just the reverse of El Nino. I hope this will be understandable. Okay, La Nina, during La Nina event, water circulation intensifies with greater convection over western Pacific and stronger trade winds. Okay, because of the stronger trade winds, more surface warm water will be shifted towards western Pacific Ocean, and it will be moved further to Asian countries as well. Okay, so as the trade wind strengthens, the pool warm water is confined to far western tropical Pacific, resulting in warmer than usual sea surface temperature in the region north of Australia. Sea surface temperature across central and eastern tropical Pacific Ocean becomes cooler here. Okay, becomes cooler than usual, and the thermoclines moves closer to the surface. So cool water from deep ocean are drawn to the surface as upwelling strengthens. Upwelling also strengthens here. So this results in proliferation of fissures on the coast of Peru, Chile, and this results in significant drop in the price because of the higher supply, because of more harvest. So convection and hence cloudiness over the region north of Australia increases as the stronger winds provide more moisture overlying atmosphere, and water circulation intensifies here. So this strengthens the Australian monsoon and the monsoon in India importantly. Okay, so that is about El Nino, La Nina, effects of El Nino events. These are important from prelims point of view, from mains point of view, and also from in the prelims examination to test your understanding skills. Such kind of questions may be asked. So thanks for watching. Please watch again if you have not understood the concept. It is somehow confusing. Please keen to watch this video. Thanks for watching.